So in this lesson, I'll be going through 6 fundamental ways of remembering all the theorems in Euclidean geometry. And if you struggle to remember which theorem to use when, this is an important lesson for you to pay attention to. So we'll be going through first theorem on the diameter and angle facing a diameter, and we'll be breaking it down. So the question says, determine with the reasons the unknown angles, always the center of the circle, and what we need to really know that in Euclidean geometry, we always have to mention a statement and we have to justify that with the reason, and then we'll get 4 marks for that. So we're given ABC, we need to find what X, Y, and Z are. And we know that this angle AOB is 110, angle BAO is 35. We need to find what X is, Y is, and 90 is. But since we know that AC is the diameter, as you can see in the diagram, we know that this should be 90 degrees. So we can write that down. Say angle ABC equals to 90 degrees. ABC simply means A, B, and C, and the hat is where the angle is, which is in B, 90 degrees. Why are we saying that? The reason is angle in a semicircle. Or you can say an angle facing a diameter. So now that we know that that's 90 degrees, that can help us find angle Z, or the size of Z. How do we do that? We know that the sum of angle 35 plus 90 plus Z should give us 180. Why are we saying that? We're saying that angle BAC plus angle ABC plus angle BCA should be equals to 180 degrees. Now are we saying that sum of angles in a triangle, sum of angles in the triangle add up to 180. So what is BAC? BAC is given as 35, and ABC, we deduce that to be 90 degrees. And angle BCA is Z, which is equals to 180 degrees. So we isolate Z, we take the 35 and 90 to the right hand side of the equation. And when we do that, we know that they will change the sign from positive, both positive to both being negative. 180 minus 35 minus 90 will give us 55 degrees. So we know that this angle Z equals to 55 degrees. So now we can go on and try and find what angle Y is, what angle X is, and how do we go about that. What we need to understand is that AO is radius, OB is also a radius, OC is also a radius. Why are we saying that? Remember the question said O is the center of the circle. Any line drawn from the center to the circumference will be our radius. So A, AO, BO, CO are what we call radii in plural. So which now, if you observe angle AOB, it'll give us a triangle. We look at this triangle. This will be B, this will be O, and this will be A, and we know that A is equal to 35 degrees. We know that these two sides, these are equal. So our properties of an isosceles triangle is that when the two opposite sides are equal, the base angles are also equal, meaning that we could say that angle X is equals to angle 35, because the opposite angles are equal, the base angles at the bottom there should be equal. And our reason, equal angles opposite equal sides. And this is the reason that many students struggle with, but it's good that you can always remember it. When you have an isosceles triangle, you'll be using this reason a lot. We found what X is equals to. X is equals to 35. So we need to find what y is equals to. And that's simple. We know that when we add y and x, we should get 90 degrees. We've concluded that from ABC. So what we need to simply do is just to substitute 35 with the x. And we solve for y. We solve for y, we keep y on the left hand side. Then we take 35 to the right hand side. And we're going to say 90 degrees minus 35. And it should give us 55 degrees. If we wanted to, we could use the same reasoning we used of an isosceles triangle. Now, what do I mean by that? We know that this is 55 degrees. We know that these two sides are equal. So we know that y should be equals to 55 as well. And the reason will be equal angles, opposite equal sides as well. And that will be it really for the first theorem, angle facing a diameter. Let's move on to the next theorem.